In the previous session, we discussed drivers and monitors, and then like it was a basic driver and monitor what we discussed using some Verilog constructs. Let us now review scoreboards. Scoreboards are kind of a central warehouse where we keep what transactions actually went to the DUT, what was the expected data, whether the transaction resulted in a success or a failure. So it is a central place where we keep all the data so that we know like what was the performance of our test, like how many transactions were sent onto the DUT, how many of these passed, how many of these failed, what was the error signatures, and so on. So scoreboard, so in general, if you see like what do we need for a scoreboard, we need some additional data structures which can hold the expected data and then compare it against what we receive from the DUT. Correct? Some crude way to think is like some kind of array in which what transactions we have sent out, and then what when the responses comes back, we check our data is matching to the return data or not. Correct? So we need some kind of data structure. So in Verilog we didn't have something called associative array. In Verilog we had a concept of fixed arrays. Correct? In that case we could have made this scoreboard, like we are creating a array of like each location of the array is mem data with size, and then this in the Verilog it might be the entire address width. Like if the address width is 5, these locations will be 32, so we'll have a fixed 32 locations. But in SystemVerilog we could use associative array in which we don't allocate all 32 locations at once. Whenever the locations are getting used, we will allocate and deallocate from there. So let's directly go over to the code, our example. So in the previous example, when we discussed monitor, you might have noticed that we were tapping the interface to the memory model, and then based on the chip select and read and write, we were deciding whether the transaction was a read or a write, and we were displaying to the log console that okay, this was the read transaction, what was the address and data, and similarly for write, what was the address and data. Correct? So this was the simplest monitor what we developed in the previous session, but the monitors can do something extra because we need because the monitor is already tapping the interface, and we are talking about a central warehouse where it has to count the number of failures or a pass, like failures passed, and then how many transactions were sent. This monitor could also send that information to the scoreboard. Correct? So we have enhanced our monitor to look like this. So it has additional signals called mem check enable, mem address, and mem check expected data. So these are the three additional variables what we have. And again, like the address would have to be based on the address width, and then expected data has to be with respect to data width. Correct? Now in as discussed previously, like if it was a Verilog, we would have to make this as a fixed array. But like for now, assume that we know associative array, and then we are giving we are creating an associative array with this index being the key, and this can store the key is of this type. So for now, assume that whatever address we sent out to the memory model is the key to that associative array. So if you see this, what we are doing when the chip select is high and m read write is set, we know that this is a read transaction. So we are sending the whenever we do a read, the memory model will give us a read data, and then we want to check whether this read data is the expected data or it's a wrong data, so that we could do without even looking at the waveform, we can decide whether the test passed or failed. Correct? So this is the read part of it. During write, when actually we are performing a write, we don't want to do anything to the score, we don't want to pass any packet to the scoreboard, but what we are doing, we are creating a expected data for that location. So whenever there is a write to a particular memory model, we take that address forms the key to this scoreboard memory, and then we write the W data in this. Subsequently, when the read occurs to that address, this three variables will be sent to a central scoreboarding module, which will take these values and then check against this mem scoreboard to decide whether the check passed or failed. Correct. So this monitor now like does two things. One, it displays the log messages whether the transactions are read or write, and then when it is a write, it creates the expectation in the memory structure. When it is a read, it sends a packet to the scoreboard to check whether the received data for a read was correct or not. So now let's go to the scoreboard module. Again, this is a simplest scoreboard like you would ever see. So what it does, if memcheck enable is high, so this memcheck enable will only be high for a read, because we know that like this is coming from here. Correct. So when memcheck enable is high, it is passing the expected check address and the expected data. Correct. So what we are trying to do here is we are trying to index our scoreboard memory with this address, and then checking whatever data we receive from this memory structure. We are checking against the expected data what we have received from the read data. If it passes, then we say a pass, and if it fails, then we say an error. So now, like if there was an error during a read or during a read, then we would get an error message saying that this was an error, and then we have sufficient details along with it. Okay, this error occurred for this address, and what was the expected data, and then what was the actual data what we have received. Correct. So this is like a simplest scoreboard what we have. Let's run it through, and then so if you see, like our test bench remains the same. We have two transactions which are sent out from this module. So one write at 7 with data AP, and then read at 7, and then write at address hex 12 with data hex CD, and then we are reading at this. Correct. So if you say this, like the first the write happened, then we perform a read. As soon as the read happened, we are passing a packet to our scoreboard, which will actually perform a check whether the expected data matches to the actual data returned from the memory model, and then we see a pass, because in this case the actual data and the expected data are same. Correct. And similarly, this is the case for the second transaction as well. So this is again a scoreboard which will take care of it. Correct. Like now as we go ahead, now in this case we have only sent two transactions. Correct. Again, like this is not a fully verified model. Correct. We need to sweep it across all the address, and then sweep it across all the data and various combinations of structures. Correct. This we'll go and review in the next session.